Hello guys, welcome again to this video, and this is basically the fourth chapter of our lesson. So as you know, we have started before the introduction to sets, and we have also introduced the concept of classical probability. In this section onwards, we are trying to look forward to the different possibilities of classical probability, how to do the problems, and how to make sure that we do have the necessary tools to solve the conditional probability and the law of total probability theorems. So we shall start with some basic theory about it. So let me give the heading to our topic. It's basically classical probability. Now, in classical probability, as we have already learned about set theory, we do know about the following things already. So let me write down what we already know. We know about definition of classical probability. We also know about set theory, and in addition to classical probability and set theory, we also do know about how to use different formulas such as union, intersection, complement, and the basic definition, which is, I will write that in bracket, P equals to mod n by mod s, which is the definition of probability. In this section, however, we are trying to look forward to different formulas regarding classical probabilities. That is, we will start off with something called conditional probability. So let us just cover the theory portion first, and then we shall move on to higher things. So conditional probability. So what is conditional probability? As the name suggests, conditional probability is the probability of events conditioned upon some other event. So when two events A and B with probability of B not equals to 0, or in other words greater than 0, then the probability of A given B occurs. So note this part, the probability of A given that B occurs is, now this is the notation for conditional probability, it is probability of A divided by B. So whenever you see this notation, it basically means that we are trying to find the probability of A, which is in the numerator, given that B has already happened. So in this case, the event B or the set B actually acts as a sample space for our event A. That's what we are trying to find here. As I'll give you some examples, you will understand what I'm saying here. But by definition, the probability of this is basically probability of A intersection B divided by probability of B. And of course, as I have mentioned, probability of B must be not equal to 0. Okay. So this is the definition which we are trying to find, and this definition can be used in multiple ways, but then again we can also use conditional probability by logic as well, just by finding the sample space of B and then counting the number of elements which satisfy our favorable case. So this is the conditional probability. Now some one of the important rules in classical probability about conditions is, when you have probability of A complement B, this is simply written as 1 minus probability of A by B. So this is important because the event B is given as a barrier here, so it basically acts as a sample space, as I've said before. So with this in mind, let us see how we can define the following problem. Considering we toss three coins simultaneously what is the probability of getting at least two heads given that at least one head has occurred. So we basically want to find that if we are given three coins and we want to find that what is the probability of getting at least two heads given that three heads of at least one head has occurred. So you see this is basically a conditional probability. You are also given like two events. One of them has to be found the probability of and the other one is the given one, right? So we can solve this in basically two ways. I shall show you both the methods. So this is just a matter of taste. So solution 1, let me change the ink actually. Green seems better. Okay. So tossing a coin 3 times. Tossing a coin 3 times means the sample space S, as I've shown in previous examples in the previous videos, it's basically equal to the following. So as you can see that a coin may have like two different results, right? Heads or a tails. Now if you toss a coin twice, it will give you like heads tails, tails or tails heads, right? So in any order they can be possible. Similarly, tossing a coin 3 times shall give you something like this: H H H H H T H T H T H H H T T T H T T T H T T T. So this gives you a total of mod s equals to 8, right? Now this is the sample space for tossing a coin 3 times, a fair coin of course. Whenever nothing is mentioned about the coin, we assume it's a fair coin. That is, the probability of getting a heads or a tails is basically equal. Now when you have mod s equals to 8 and you want to find out the two events, so we first define the two events as follows. So event A, getting at least one head, right? And then we have event B, getting at least two heads. So these are our two events, right? Now as we can see from the sample space, we can easily point out which event corresponds to what. So let me write it down. So for event A, probability of A should be equals to probability of the following set. What numbers would be included getting at least one head? So we will include everything that has only one head, right? So basically it should be H H H H H T H T H T H H H T T T H T and T T H. How many entries are there? There are 7 entries. So probability of this set by the classical definition of probability should be mod of this set, which is basically 7, divided by mod of S, which gives you 7 upon 8. So this is the probability of A, right? Okay. What is the probability of B? The probability of B then would be the probability of the set where you have at least two heads, which is basically H H H H H T H T H and T H H, right? This gives me 4 upon 8, which is 1 by 2. Okay. So this gives me probability of A and B. Now consider the event A intersection B. Considering A intersection B. So getting at least one head and getting at least two heads, as you can see, getting at least one head basically has all the features that even B also has. So getting at least one head would also imply that at some point it would also get at least two heads, right? So that means A intersection B is basically B, because B is a subset of A. Why is that? Because B is a subset of A, right? A proper subset, in fact. This means that what we can do is as follows. Since we have been conditioned on the event A, what we can do is probability of A given wait one second, it's basically the opposite. So what we can do is something like this. Probability of B given A is equal to probability of A intersection B divided by probability of A, right? Because we have been conditioned on the event 1. And now as we know that A intersection B is basically B, so it's basically probability of B divided by probability of A. And probability of B, as we can see from here, is 1 by 2, and probability of A was 7 by 8. This gives me 1 by 2 into 8 by 7, or in other words, after cancelling, we get the answer as 4 by 7, right? So this is the final answer, which you would not expect at the first sight, but you can do that if you wanted to. I'll show you the next method as well, where we actually use the logic more rather than doing it in a more converse way like this. We can use our logic by eliminating some of the elements and introducing the concept of using sample space and modified sample space. So let us move on to solution number 2 as well. So solution 2 would mean something like this. Now again, the sample space S would be something like this. I'll just write it quickly. Sample space would be HHH, HHT, HTH, THH, HTT, THT, TTH and TTT, right? This is the sample space. Now given that mod is equals to 8 and this is a sample space, we define our two events as follows, where event A would be getting at least one head, and event B would be getting at least two heads. Now one way to find out the given probability, which we were doing, is if we want to find probability of B given A, we can consider A as our sample space, right? So how to find A as your sample space? First we need to list the event A. So the event A can be listed as follows. Now the event A basically here is, we just use the curly brackets and getting at least one head, right? So this would mean that H H H H H T So we are considering all the cases with 2 heads right now. And so see, first we considered the case with 3 heads, then 2 heads, and now we move on to 1 head, which is basically HTT, THT, and then we have TTH. So this completes all the cases where you have like 2 heads. So this is our new sample space, and the event B is simply HHH, HHT, HTH, and THH, right? As you can see clearly, we can see that P is a subset of A, and probability of B should just be equal, because A is the sample space here, and this is what we want. We only want to find B here, given that A is a sample space, right? So this should be mod of B by mod of A, isn't it? So what is mod of B? It's 4. What is mod of A? It's 7. As you can see, it's very easy to find out in this way as well. So this completes the problem. So just a quick review that there are 2 kinds of solutions to conditional probability problems. One of them you can use the trivial definition, which is this one, probability of A intersection B divided by probability of B, but of course the denominator must be non-zero. And the other definition revolves around the fact that you can actually consider the set which you are conditioning on to be the sample space, and then find out the required probability in that sample space, which can be done very easily, as you have shown here, right? Okay, so this concludes our video for today, and in this lecture we shall discuss no more, but from the next lecture we would try to solve a few more problems, and we would try to know about the law of total probability as well, and in further lectures Bayes' theorem and its applications, which would conclude our journey for classical probability. So this ends the video, and also please do download the Breter's Math app, which the link can be found in the description, and it's basically a full app for all the statistical calculators and tools, and the notes related to this video can also be found correspondingly in the app. Thank you very much.